Good day, viewers. I am creating these videos to help teachers of mathematics support their learners in making sense of mathematical ideas through the use of manipulatives and visuals. And today, what I want to focus on is simplifying fractions. So let's look at a fraction like 6/9. How can I see and make sense of how this fraction simplifies, why the factor of 3 is important, and things of this nature? Well, there's a couple of different ways I might go about it. And one of those ways, or a couple of those ways actually, use quiz and air rods. And in using the quiz and air rods, I'm going to set up the fraction 6/9. So I'm defining the blue rod to have a value of 1 in effect. And so if I define the blue rod to have a value of 1, each of the other rods takes a value in the ninth family. So the white rod is 1/9, the red rod is 2/9, and so on. And that makes the green rod 6/9. So how can I see that this will simplify to 2/3? Well, one of the ways I might do that is to ask learners, can you create a picture with those two lengths, but that only uses one rod? And I don't mean a single rod there, I mean one type of rod. So only the red rod, or only the green rod, or only the purple rod. And I can create that. If I use the light green rod here, I can create something that's the same length as the top, and then I can create something else that is the same length as the bottom. And I can see there, I can ask the question now, so how many of those rods did you use? Well, I used 2 rods here and I used 3 rods there. So that gives me the simplification 2/3. And what I'm saying here, in effect, is I'm splitting that 6 into 2 3s. I'm splitting that 9 into 3 3s. And so because there is a factor of 3, I can remove that factor of 3 and just consider this, rather than being 6, rather than this being 2 3s and 3 3s, I can consider this as 2 rods and 3 rods. Now, this model is fine. However, if we then start to explore a different fraction, like the fraction 18, I'm just going to set up my 18. That's that one. Over 24. So here we now have the fraction 18/24. In effect, I'm defining this whole length to be 1. And so this is 18/24 of that length. So 18 out of 24, 18/24 of 1 whole. Then the issue we might have here is it's all well and good if a learner spots that I could use a 6 rod to replace these. So I can use a 6 rod here, and I can use a 6 rod here. But a learner might not spot that straight away. A learner might spot that I could use a 2 rod instead. And in particular, that I can use 9 2 rods here, and that I could use 12 2 rods there. But from here, of course, we can say, right, well, I've used 9 2 rods, and I've used 12 2 rods. But at this point, it's unclear how I'm going to bring the factor of 3 into play to eventually get down to 3/4. It's unclear how I'm going to do that. The bar saying something like, okay, can you find a bigger rod? But it's unclear how I would go via 9/12 to get to 3/4. Now, there is an alternative way of viewing this. And again, I'm going to start with 6/9. There is an alternative way of viewing this, which doesn't have the same limitation. And that is, rather than try and replace all these with a different rod, with one single rod, can I find a set of rods here and a set of rods here that will make that length, where the rods can be different, but there has to be the same number of rods in both lines. So I can use one color rod to replace this, and I can use one color rod to replace that. And those rods can be different colours, but I have to end up with the same number of rods here as I do there. Well, what we can see here is I could replace the top line with 3 2 rods, and I could replace the bottom line with 3 3 rods. And now I can see, well, okay, so I've got 3 2s and I've got 3 3s, and what I can physically do now is actually separate those out and say, well, this is just the repeated comparison. If this is 6 compared to 9, then this is the repeated comparison, 2 compared to 3. And so what I might do here, and this obviously is basically saying I'm writing the 6 as 2 times 3, and I'm writing the 9 as 3 times 3. But what I'm saying is that's because I'm just repeating that comparison. I don't need to repeat that comparison. I can just look at a single comparison. 6 compares to 9 as 2 compares to 3. And so I get the result 2/3. Or, of course, I could at that point have said I've just divided it into 3 equal pieces if you prefer an operational approach to simplifying fractions. I've divided that 6 into 3 equal pieces. Each piece is 2. I've divided the 9 into 3 equal pieces. Each piece is 3. Now, this model doesn't have the same limitation as this one when it comes to continually having to replace rods, because now, again, if I set up my, I'm going to make it a little bit higher here, if I set up my 18/24, then I could say, right, well, because I'm allowed to use different color rods now, I could say, well, I can replace this with 2 9 rods, and I can replace this, and I'm going to have to add this in. Obviously, if you only have a base 10 Cuisenaire rather than a base 12 Cuisenaire, that makes it slightly more difficult, but I can replace this with 2 12 rods, and now I'm obeying the same rules. I have the same number of rods on the top and on the bottom, but I have 9 12s, and I'm going to pull those out underneath there now to say what I actually have is 9 12ths. So I had 18 and 24, but that is just the same as 9 compared to 12. So actually I can eliminate that part now. But now I can do, now I'm free to do the same thing again. Can I find rods that will replace this or replace that, where I have to use the same number of rods in both lines? And so I can see now that I can replace that 9 with 3 3 rods, and I can replace that 12 with 3 4 rods, and that's giving me the 3/4. I have literally broken the 9 into 3 3, so I've divided the 9 into 3 equal pieces. I've divided the 12 into 3 equal pieces. Each of these pieces is now a 3. Each of these pieces is now a 4. And again, at that point, I can separate them out and say, well, it's just this comparison, 3 compared to 4. So those are a couple of models for Cuisenaire. There is a third model for Cuisenaire that we might use, but before I do that, I'm going to come back to, I want to look at counters, because doing this with counters, and I'm just going to do the 6/9 here, but doing this with counters gives us a really nice double view of fractions, which can be useful, particularly when we come to looking at fractions and percentages and things like that. So here we can see 6 out of the 9 counters are yellow. It doesn't matter that the other 3 are green, although it does show us that 6/9 and 3/9 makes the whole. Okay, but importantly here, 6/9 of the counters are yellow. But if I now rearrange this into an array, and of course the side length 3 there is important. If I arrange this in an array, I can actually see that fraction 2/3 in 2 different ways. I can see that 2 out of the 3 rows are yellow, but I can also see that in any column, 2 out of the 3 counters are yellow. And like I say, when it comes to percentage and being able to think about percentage in 2 different ways, that's actually quite useful. So being able to see the fraction in two different ways, 2 out of 3 rows, but 2 out of 3 counters in each column, is quite nice. So that's a nice model for looking at equivalent fractions. And obviously the fact that we've arranged it into an array with a width of 3 or a length of 3 is what's pointing us towards that factor of 3. Now we could do something similar to that in the Cuisenaire and with the Cuisenaire rods. If we say, rather than build a length of 6 and a length of 9, can you build me an area of 6 and an area of 9? But importantly, can you make both areas have one dimension the same? And if we look at this, then we can see that I can do that. I can build a 6 here, 2, 4, 6, there we are. And I can build a 9 here. And I can see that both of these rectangles, this one's obviously a square, but both of these shapes have a dimension of 3. So then it's okay, well, what is the other dimension? Well, the other dimension is 2 and 3. So this is saying, well, if we say ignore the width, if we call it width in this case, and just look at the length, then this is showing us that 6 is to 9 as 2 is to 3. Now, of course, that requires a little appreciation of the fact that for two rectangles with the same width, their length is proportional to their area. So 6 is to 9 as 2 is to 3, only because these rectangles have the same width. And if the rectangles had a different width, that wouldn't necessarily hold true. So it requires that sort of appreciation, but it can be a nice model, particularly for that one, if eventually we're going to be modeling algebraic fractions, and algebraic fractions involving things like squares, where we have to show the variable or the x squared as an area. Having seen that previously can be useful. So that's just a quick video about how we might use manipulatives to make sense of simplifying fractions. As always, I'd like to give my thanks to mathspot.com and its creator, Jonathan Hall, for creating such a wonderful website that provides all of these manipulatives virtually so that I can use them for videos. That's not the only reason he does it, but it is a useful byproduct. And if you've never been to mathspot.com before now, I would heartily suggest going along to it. It has a whole wealth of material on there, not just the virtual manipulatives, but all sorts of things that are useful for teachers of maths. And if you are more interested in using manipulatives and visuals to support making sense of mathematics, I'd urge you to go along to my website, visiblemaths.co.uk, and amongst the things you'll find on there, one of the things you'll find is a link to my book, Visible Maths, and the publisher's website is on there where you can see some sample pages and place an order. I'm going to be trying to make these videos regularly throughout the lockdown period and potentially beyond. So if there is a particular area or a particular idea of maths that you feel like you'd like me to explore, please do get in touch and I'll do my best to create a video for you. Thank you very much.